Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 1, May-June 2021. Let's get started. The total cost of a taxi journey is calculated as $0.50 per kilometer plus $0.40 per minute. Calculate the total cost of a journey of 32 kilometers that takes 30 minutes. So in this case, the total cost will be the cost per kilometer, which is $0.50 times the number of kilometers traveled, which is 32, plus the cost per minute, which is $0.40 times the number of minutes for the journey, which is 30 minutes. And so when we type this into the calculator, we get a total cost of $28. The total cost of a journey of 100 kilometers is $98. Show that the time taken is 2 hours. So in this case, we've been given the total cost, which is $98, and we are asked to find the time taken and show that it is equal to 2 hours. And so we have the cost per kilometer, which is $0.50 times the total kilometers traveled, which in this case is 100 kilometers, plus the cost per minute, which is $0.40 times the unknown time taken, which we are representing as x, is equal to 98. And so when we simplify this further, we get 0.40x equals 48. And when we make x the subject, we get 120. And take note that 120 is in minutes, and so we need to convert it into hours by dividing 120 by 60. And when we do that, we get the time taken as 2 hours. 3 taxi drivers travel a total of 8,190 kilometers in the ratio 5:2:7. Calculate the distance each driver travels. The first driver travels a total of 5 divided by the total ratio, which is 14 times 8,190 kilometers, and that is equal to 2,925 kilometers. Driver 2 travels a total distance of 2/14 times 8,190 kilometers, and this gives us 1,170 kilometers. Driver 3 travels a total distance of 7/14 times 8,190 kilometers, and that gives us 4,095 kilometers. After midnight, the cost of any taxi journey increases by 45%. One journey costs $84.10 after midnight. Calculate the cost of the same journey before midnight. So in this case, the price after midnight, which is $84.10, is equal to 145% of the price before midnight. So when we rearrange this equation and type it into the calculator, we get the price before midnight as $58. The diagram shows the speed time graph for the first 180 seconds of a train journey. Find the acceleration in meters per second squared of the train during the first 50 seconds. So we know that to find the acceleration, that is equal to the change in the speed divided by the change in the time. And so during the first 50 seconds, we have the acceleration equals 9 minus 0 meters per second divided by 50 minus 0 seconds. And when we type this into the calculator, we get the acceleration as 0.18 meters per second squared. After 180 seconds, the train decelerates at a constant rate of 1,944 kilometers per hour squared. Show that the train decelerates for 60 seconds until it stops. Take note that acceleration and deceleration are pretty much the same things. The only difference is that during acceleration, the speed of the car is increasing, and during deceleration, the speed of the car is decreasing. And so we can use the formula for finding acceleration in this case. Since we are interested in finding the time duration for the deceleration, we make t the subject in the formula, and that is equal to the change in speed divided by the acceleration. So from the graph, just before the train starts to decelerate, it was traveling at a speed of 9 meters per second, and when the train stops, its speed will be 0, and so we have the change in speed as 9 minus 0 meters per second divided by the acceleration, which is 1944 kilometers per hour squared. So to get our answer in seconds, we need to convert kilometers per hour squared into meters per second squared. And we can do that by multiplying 1944 by 10 cubed and dividing by 3600 seconds squared. And when we type this into the calculator, we get the time duration as 60 seconds. Complete the speed time graph. So we've already shown that the time duration for the deceleration is 60 seconds. And so when we add 60 seconds to 180 seconds, we get 240 seconds. And so it means that the train comes to a stop at t equals 240. And so to complete the graph, all we need to do is draw a straight line from where the graph ended at t equals 180 down to the horizontal axis at t equals 240 seconds. Calculate the average speed of the train for the whole journey. So to find the average speed of the train, we need to calculate the total distance traveled by the train during the entire journey divided by the time duration for the entire journey. And so to find the total distance traveled, that is the same as the area under the graph. Looking at the area under the graph, we have a trapezium. And so we can use the formula for finding a trapezium to find the total distance traveled by the train. And so we have half times 130 plus 240 times 9 meters. And when we type this into the calculator, we get 1665 meters. We also know that the total time duration for the journey is equal to 240 seconds. And so the average speed of the train for the whole journey is equal to 1665 meters divided by 240 seconds. And when we type this into the calculator, we get an average speed of 6.9375 meters per second. The diagram shows a solid cone and a solid hemisphere. The cone has radius 2.4 centimeters and slant height 6.3 centimeters. The hemisphere has radius r centimeters. The total surface area of the cone is equal to the total surface area of the hemisphere. Calculate the value of r. We've been given the curved surface area of the cone as A equals pi RL, and we've also been given the curved surface area for the sphere, which is A equals 4 pi r squared. So from the question, we've been told that the total surface area of the cone is equal to the total surface area of the hemisphere. The total surface area of the cone is equal to the curved surface area, which is pi RL, plus the flat circular surface area at the bottom, which is pi r squared. And for the hemisphere, the total surface area is equal to its curved surface area, which is equal to 4 pi r squared divided by 2, giving us 2 pi r squared, plus the flat surface area at the top, which is pi r squared. And so when we simplify this equation further, we have r is equal to the square root of rl plus r squared divided by 3. So the small r is the radius of the cone, and that is 2.4 centimeters. L is the slant height of the cone, and that has been given as 6.3 centimeters. And so when we slot in all these values and type it into the calculator, we get the value of r as 2.64 centimeters, correct to 3 significant figures. The diagram shows a solid cone with radius 7.6 centimeters and height 16 centimeters. A cut is made parallel to the base of the cone and the top section is removed. The remaining solid has height 12 centimeters as shown in the diagram. Calculate the volume of the remaining solid. The volume V of a cone with radius r and height h is V equals 1 over 3 pi r squared h. The volume of the remaining solid is equal to the volume of the big cone minus the volume of the small cone which has been removed. And so the volume of the big cone will be 1 over 3 pi the radius of the big cone squared times the height of the big cone. And the volume of the small cone will be 1 over 3 pi times the radius of the small cone squared times the height of the small cone. So we already know the radius of the big cone, which is 7.6 centimeters, and we also know the height of the big cone, which is 16 centimeters. We've not been given the height of the small cone, but we can find it by subtracting 12 from 16 centimeters, and that gives us 4 centimeters. We can apply the similar shapes method to find the radius of the small cone. And so when we set up our ratio, we have the radius of the small cone divided by the radius of the big cone is equal to the height of the small cone divided by the height of the big cone. And so when we slot in all the values that we have, we get the radius of the small cone as equal to 4 over 16 times 7.6 centimeters, and that is equal to 1.9 centimeters. So we come back to our equation for finding the volume of the solid and slot in the values of RBC, HBC, RSC, and HSC. And so that gives us 1 over 3 pi times 7.6 squared times 16 minus 1.9 squared times 4 centimeters cubed. When we type this into the calculator, we get the volume of the remaining solid as 953 centimeters cubed, correct to 3 significant figures. The exchange rate is €1 equals $1.142. Johan changes $500 into euros. Calculate the number of euros Johan receives. Give your answer correct to the nearest euro. And so after setting up our ratio, the number of euros Johan receives will be equal to $500 divided by $1.142 times €1. And when we type this into the calculator, we get 438 euros, which is correct to the nearest euro. Johan buys a computer for $329. The same computer costs 275 euros. Calculate the difference in cost in dollars. So first off, we need to convert 275 euros into dollars. And to do this, we need to set up our conversion ratio. And this gives us the cost of the computer equals 275 euros divided by €1 times $1.142. And when we type this into the calculator, we get $314.05. And so the difference in cost will be 329 minus $314.05, and this gives us a final answer of $14.95. Lucy spends 3/8 of the money she has saved this month on a book that costs $5.25. Calculate how much money Lucy has saved this month. And so if we represent the amount of money Lucy has saved this month as Y, we have 3/8 times Y equals $5.25. And when we make Y the subject, we have $5.25 times 8 divided by 3. When we type this into the calculator, we find out that Lucy saved $14 this month. Kamal invests $6,130 at a rate of R% per year compound interest. The value of his investment at the end of 5 years is $6,669. Calculate the value of R. In this case, we want to find the value of R. So first, let's make R the subject. When we make R the subject, we get 100 times capital A divided by the small a, all raised to the power 1 over t minus 1. The capital A in this case represents the final value of his investment, which is 6,669. The small a here represents the initial amount at the beginning of the investment, and that is $6,130. T is the time duration in years for his investment, and that has been given as 5. And so when we slot in all these values into the equation and type it into the calculator, we get the value of R as 1.70, correct to 3 significant figures. The diagram shows triangle ABC. X is a point on BC. AX equals 10.6 centimeters. XC equals 6.4 centimeters. Angle ABC equals 58 degrees. And angle AXB equals 78 degrees. Calculate AC. So looking at the diagram, it will be easier to find the length of AC using the cosine rule. And so when we apply the cosine rule, we have AC squared equals AX squared plus XC squared minus 2 times AX times XC cosine of angle AXC. So AX equals 10.6, XC equals 6.4, and angle AXC equals 102 degrees. The value of angle AXC can be found by applying the fact that angles on a straight line add up to 180 degrees. And so by subtracting 78 degrees from 180 degrees, we get the value of angle AXC as 102 degrees. When we slot in all these values into the equation and type them into the calculator, we get the value of AC as 13.5 centimeters, correct to 3 significant figures. Calculate BX. By looking at the diagram, we can easily find BX by applying the sine rule. And so by applying the sine rule, we have BX divided by sine 44 degrees equals 10.6 centimeters divided by sine 58 degrees. When we make BX the subject, we have 10.6 divided by sine 58 degrees times sine 44 degrees centimeters. When we type this into the calculator, we get the value of BX as equal to 8.68 centimeters. Calculate the area of triangle ABC. By applying the area of a triangle formula, we have area of triangle ABC equals half of BC times AC times sine ACB. We've already found AC as 13.5 centimeters, and we know that BC is equal to 8.68 plus 6.4 centimeters, giving us 15.08 centimeters. So now we can find sine of ACB by applying the sine rule. When we apply the sine rule, we get 10.6 divided by sine ACB equals 13.5 divided by sine 102 degrees. So since we are interested in finding sine ACB, we make it the subject, and we have sine 102 degrees times 10.6 divided by 13.5. And so when we type this into the calculator, we get the value of sine ACB as 0.768. And so when we slot in the values of AC, BC, and sine ACB into the area of triangle ABC equation, we get the value of the area as 78.2 centimeters squared, correct to 3 significant figures. In the Venn diagram, shade the region P complements union Q. Since we are dealing with a union, we can shade each region separately. First off, let's shade the region P complements. So P complements is all the areas outside the region P. And now let's shade the region Q. And so when we do this, this is how the shaded region is supposed to look like. There are 50 students in a group. 34 have a mobile phone, 39 have a computer, 5 have no mobile phone and no computer. Complete the Venn diagram to show this information. So first off, let's start with the number of students who have no mobile phone and no computer. These number of students are 5 in total, and so we'll put them in this side of the Venn diagram. After taking out the number of students who have no mobile phone and no computer, we have 45 students remaining. When we add the number of students who use a mobile phone to the number of students who use the computer, we get a number greater than 45. This is because some students use both a mobile phone and a computer, and so they've been counted twice. And so to find the number of students who use both a mobile phone and a computer, we subtract 45 from the sum of 34 and 39, and this gives us 28. So now that we found the number of students who use a mobile phone and a computer as 28, we can find the number of students who use the mobile phone only as 34 minus 28, and that gives us 6. And the number of students who have a computer only is equal to 39 minus 28, and that gives us 11. The Venn diagram shows the number of students in a group of 30 who have brothers, sisters, or cousins. Write down the number of students who have brothers. So the number of students who have brothers is equal to 2 plus 2 plus 3 plus 1, and that is equal to 8. Write down the number of students who have cousins but do not have sisters. And so that number is equal to 3 plus 8, and that is equal to 11. Find the number of students who do not have a brother or a sister or a cousin. And from the Venn diagram, that number is equal to 2. Use set notation to describe the set of students who have both cousins and sisters but do not have brothers. So cousins and sisters will be represented as C intersection S, but do not have brothers will be represented as intersection B complement. One student is picked at random from the 30 students. Find the probability that this student has cousins. And so this probability is equal to the number of students who have cousins divided by the total number of students. And so the number of students who have cousins is 3 plus 1 plus 7 plus 8. And so we have the probability as 19 over 30. Two students are picked at random from the students who have cousins. Calculate the probability that both these students have brothers. So the number of students who have cousins is equal to 19, and the number of students who have a brother and a cousin is equal to 4. And so in the first case, we have a probability of 4 over 19. And during the second pick, this number reduces, and so we have 3 over 18. And so to find this probability, we have 4 over 19 times 3 over 18. And when we type this into the calculator, we get 2 over 57. One student is picked at random from the 30 students. Event A, this student has sisters. Event B, this student has cousins but does not have brothers. Explain why events A and events B are equally likely. This is simply because the number of students available under both events are equal. Simplify. X squared minus 25 divided by x squared minus x minus 20. So for the numerator, we can identify that as a difference of 2 squares, and that is x squared minus 5 squared. And for the denominator, we can expand that as x squared plus 4x minus 5x minus 20. And so by applying the technique for difference of 2 squares, we have x plus 5 times x minus 5 in our numerator, and by factorizing our denominator, we have x times x plus 4 minus 5 times x plus 4. We can rewrite our denominator as x plus 4 times x minus 5. And so x minus 5 cancels out in both the numerator and the denominator. And we are left with x plus 5 divided by x plus 4 as our final answer. Write as a single fraction in its simplest form. X plus 5 divided by x plus 8 divided by x minus 1. And so in this case, our LCM is the product of the denominators, and that is x times x minus 1. X goes into the LCM, and we are left with x minus 1, which goes to multiply the numerator, which is x plus 5, plus x minus 1 goes into the LCM, and we are left with x, which multiplies the numerator, which is x plus 8. When we expand the brackets in the numerator, we get x squared minus x plus 5x minus 5 plus x squared plus 8x. When we further simplify the numerator, x squared plus x squared gives us 2x squared minus x plus 5x plus 8x gives us 12x minus 5 divided by the denominator, which is x times x minus 1. And so our final answer is 2x squared plus 12x minus 5 divided by x times x minus 1. A curve has equation y equals 2x cubed minus 4x squared plus 6. Find dy dx, the derived function of y. So to find dy dx, 3 multiplies 2 and then we subtract 1 from 3. 2 multiplies 4 and we subtract 1 from 2. The constant gives us 0. So when we simplify this, 3 times 2 gives us 6, 3 minus 1 gives us 2, 4 times 2 gives us 8, and 2 minus 1 gives us x raised to the power 1, which is the same as x. And so we have dy dx as 6x squared minus 8x. Calculate the gradient of the curve y equals 2x cubed minus 4x squared plus 6 at x equals 4. And so the gradient of this curve at x equals 4 is the same as dy dx at x equals 4. In the previous question, we've already found dy dx for this same curve. And so all we need to do is substitute 4 into dy dx, and so this gives us 6 times 4 squared minus 8 times 4. When we type this into the calculator, we get 64. Find the coordinates of the 2 stationary points on the curve. And so we know that at any stationary point, dy dx is equal to 0. We've already found the dy dx of this curve, and that is 6x squared minus 8x. So we equate this to 0. And so we can solve this equation by factorization. And so when we factorize 6x squared minus 8x, we have 2x times 3x minus 4. And this is equal to 0. 2x is equal to 0, or 3x minus 4 is equal to 0. For 2x equals 0, we get x equals 0. And for 3x minus 4 equals 0, we get x equals 4 over 3. So now that we know the x coordinates of the 2 stationary points, we can substitute these x values into the equation to find the corresponding y coordinates. So when x equals 0, y equals 2 times 0 cubed minus 4 times 0 squared plus 6, and this gives us the y coordinate as 6. So when x equals 4 over 3, the y coordinate equals 2 times 4 over 3 cubed minus 4 times 4 over 3 squared plus 6, and this gives us 98 over 27. And so the coordinates of the 2 stationary points on the curve are 0, 6, and 4 over 3, 98 over 27. The table shows information about the mass in kilograms of each of 50 children. Complete the cumulative frequency table. For k is less than and equal to 10, we have a cumulative frequency of 3. For k is less than and equal to 25, we have a cumulative frequency of 3 plus 19, giving us 22. For k is less than and equal to 35, we have a cumulative frequency of 3 plus 19 plus 21, giving us 43. For k is less than and equal to 40, we have a cumulative frequency of 3 plus 19 plus 21 plus 5, giving us 48. And for k is less than and equal to 50, we have a cumulative frequency of 3 plus 19 plus 21 plus 5 plus 2, giving us 50. On the grid, draw a cumulative frequency diagram to show this information. So we plot the points 10, 3, 25, 22, 35, 43, 40, 48, 50, 50 on the grid. And after plotting all these points, we draw a smooth line starting from the origin and connecting all the points. Use your diagram to find an estimate of the number of children with a mass of 32 kilograms or less. And so when we map 32 kilograms on our graph, we get a cumulative frequency which represents the number of children with a mass of 32 kilograms or less as 36. This cumulative frequency diagram shows information about the height in meters of each of 100 students. The height of the tallest student is 1.83 meters. The height of the shortest student is 1.5 meters. On this grid, draw a box and whisker plot for the heights of the 100 students. So on the box and whisker plot, let's map out the maximum height and the minimum height. We've been given the maximum height as 1.83 meters and the minimum height as 1.5 meters. In addition to these heights, we also need to find the median height, the lower quartile, and the upper quartile. So from the cumulative frequency diagram, the median is 1.64, the lower quartile is 1.57, and the upper quartile is 1.71. The diagram shows a prism ABCDEF. AB equals 13 centimeters, AC equals 20 centimeters, CF equals 24 centimeters, and angle ABC equals 90 degrees. Calculate the total surface area of the prism. And so the total surface area of the prism is equal to 2 times of area of triangle ABC plus the area of rectangle ABED plus the area of rectangle BCFE plus the area of the rectangle ACFD. And so the area of triangle ABC is equal to half of BC times AB. AB is equal to 13 centimeters and BC can be found using Pythagoras theorem, and it gives us square root of 20 squared minus 13 squared centimeters. And so when we type this into the calculator, we get the area of triangle ABC as 13 square root 231 divided by 2 centimeters squared. The area of rectangle ABED is equal to 24 times 13 centimeters squared, which is equal to 312 centimeters squared. The area of triangle BCFE is equal to 24 times the length of BC, which is equal to square root of 20 squared minus 13 squared. And so this gives us 24 square root 231 centimeters squared. The area of rectangle ACFD is equal to 24 times 20 centimeters squared, and this is equal to 480 centimeters squared. And so when we substitute all these values into the equation for the total surface area, we get 1350 centimeters squared, correct to 3 significant figures. Calculate the volume of the prism. So the volume of the prism is equal to the area of the cross-section, which in this case is the area of triangle ABC, times the length of the prism, which is equal to CF. From the previous question, we found the area of triangle ABC as 13 times square root of 231 divided by 2 centimeters squared, and we've been given the length of CF as 24 centimeters. And so when we type this into the calculator, we get the volume of the prism as 2370 centimeters cubed, correct to 3 significant figures. Calculate the angle that AF makes with the base BCFE. So on the diagram, let's label this angle alpha. And so to find the value of alpha, we can apply SOHCAHTOA. And so sine alpha equals AB divided by AF. We know the length AB as 13 centimeters, and we can easily find the length of AF by applying the Pythagoras theorem. And so when we apply the Pythagoras theorem, we get AF as square root of 976 centimeters. Hence, the value of alpha is equal to the sine inverse of 13 divided by square root of 976. When we type this into the calculator, we get the value of alpha as 24.6 degrees, correct to 1 decimal place. The table shows some values of y equals 3 plus 4x minus x squared for x is greater than and equal to -1 and is less than and equal to 5. Complete the table. So when we substitute x equals negative 0.5 into the equation, we get y equals 0.75. For x equals 0, we get y equals 3. For x equals 2, we get y equals 7. For x equals 4, we get y equals 3. And for x equals 4.5, we get y equals 0.75. On the grid, draw the graph of y equals 3 plus 4x minus x squared for x is greater than and equal to negative 1 and less than and equal to 5. So all we need to do is to plot all the points in the table on the grid, then draw a smooth line connecting all the points. Write down an integer value of k for which the equation 3 plus 4x minus x squared equals k has no solutions. From the graph, we can see that the maximum point is 2, 7. And so, for any integer value greater than 7, the equation has no solutions. And one of these integer values is 8. By drawing a suitable straight line on the grid, solve the equation negative 1 plus 9 over 2x minus x squared equals 0. To determine the straight line we need to draw on the grid, let's rewrite this equation by first extracting the equation of the curve on one side of the equation. And so we can rewrite this equation as 3 minus 4 plus 4x plus half x minus x squared equals 0. And so when we maintain the equation of the curve 3 plus 4x minus x squared on one side of the equation, we have 4 minus half x on the other side of the equation. And so the straight line we will draw on the graph needs to have the equation y equals 4 minus half x. And to draw this straight line, let's identify two coordinates on the line. One set of coordinates on the line is when x equals 0, y equals 4. And when x equals 4, y equals 2. So we can go ahead and plot these points on the grid and connect them with a straight edge. After drawing this line on the grid, we note the points of intersection. And in this case, the points of intersection are 0.25 and 4.25. Find the size of an exterior angle of a regular polygon with 18 sides. The formula for finding an exterior angle of a regular polygon is 360 degrees divided by n, where n is the number of sides of the regular polygon. In this case, we've been given n as 18, and so 360 degrees divided by 18 gives us 20 degrees. In triangle ACD, B lies on AC and E lies on AD such that BE is parallel to CD. AE equals 5.2 centimeters and ED equals 2.6 centimeters. Calculate BE. And so by looking at the illustration, we can see that we have two similar shapes. And so we can set up our ratio to find the length of BE. For our ratio, we have BE divided by CD equals AE divided by AD. So we've been given AE as 5.2 and AD as 5.2 plus 2.6 and CD as 6.75. And so when we type this into the calculator, we get the value of BE as 4.5 centimeters. Two solids are mathematically similar. The smaller solid has height 2 centimeters and volume 32 centimeters cubed. The larger solid has volume 780 centimeters cubed. Calculate the height of the larger solid. First off, let's set up our ratio. Since we are dealing with volume, we need to cube our scale. And so when we make x the subject, we get 780 divided by 32 times 2 cubed, all raised to the power 1 over 3 centimeters. And when we type this into the calculator, we get x equals 5.80 centimeters, correct to 3 significant figures. PQ is parallel to RS. PNS is a straight line and N is the midpoint of RQ. Explain, given reasons, why triangle PQN is congruent to triangle SRN. So first off, we know that N is the midpoint of RQ. So therefore, RN is equal to NQ. We also know that vertically opposite angles are equal, and so the angle PNQ is equal to the angle RNS. We have two parallel lines, and so the alternate angles PQN and NRS are equal. So based on ASA criteria, triangles PQN and SRN are congruent. F of x equals 3 minus 2x. G of x equals x squared plus 5. H of x equals x cubed. Find f of negative 5. So f of negative 5 is equal to 3 minus 2 times negative 5. And when we type this into the calculator, we get 13. Find f of x. Give your answer in its simplest form. So to find f of x, wherever we see x in f of x, we replace it with the function f of x. And so that gives us 3 minus 2 times 3 minus 2x. And so when we expand the brackets, we have 3 minus 6 plus 4x. 3 minus 6 gives us negative 3. And so we have our final answer as 4x minus 3. Solve g of x equals f of x plus 37. So we've been given g of x as x squared plus 5, and we know f of x as 3 minus 2x. And so we have x squared plus 5 equals 3 minus 2x plus 37. When we simplify this further, we get x squared plus 2x minus 35 equals 0. So this is a quadratic equation, and due to its nature, we can solve it by factorization. And so we replace 2x with 7x minus 5x. And when we factorize this, we get x times x plus 7 minus 5 times x plus 7. And so we can rewrite this as x plus 7 times x minus 5 equals 0. So x plus 7 equals 0 gives us x equals negative 7, and x minus 5 equals 0 gives us x equals 5. Find f inverse of x. So we've been given f of x as 3 minus 2x. So we replace f of x with x and replace x with y. So now we have x equals 3 minus 2y. When we further simplify this and make y the subject, we get 3 minus x divided by 2. And this is the same as f inverse of x. So f inverse of x is also equal to 3 minus x divided by 2. Find h of f of x plus g of x. Give your answer in its simplest form. H of f of x gives us 3 minus 2x all cubed plus g of x, which is x squared plus 5. By applying the cubic expansion to 3 minus 2x all cubed, we get 3 cubed minus 2x cubed minus 3 times 3 squared times 2x plus 3 times 3 times 2x squared. And now we have our plus x squared plus 5. So when we further simplify this and add up all the like terms, we get our final answer as negative 8x cubed plus 37x squared minus 54x plus 32. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.